Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In cyclohexane ring flip equilibrium, the equilibrium constant K is equal to equatorial, axial, reflects the conformational preference of the substituent R for the equatorial position. This preference is quantified by the A value, conformational energy difference, delta G degree. A larger, bulkier substituent has a greater preference for the equatorial position, giving a larger K. The relationship is K is equal to exp, delta G degree RT, where delta G degree is the A value. Moving on to the next step. R is equal to H, there is no preference, both positions are identical for H, so K is equal to 1. A value 0 kilocalories per mole. R is equal to CH3, methyl A value 1.74 kilocalories per mole, giving K 18 at room temperature. R is equal to at ethyl A value 1.79 kilocalories per mole, giving K 23, slightly larger than methyl due to modest additional bulk, but ethyl's effective A value leads to K tilde 23. R is equal to IPR, isopropyl, CH, CH3, to A value 2.21 kilocalories per mole, giving K 38 at room temperature. Moving on to the next step. A. R is equal to H, K is equal to 1 matches, S. B. R is equal to CH3, K is equal to 18 matches, R. C. R is equal to at K is equal to 23 matches, Q. D. R is equal to IPR, K is equal to 38 matches, P. And for the final step. H cannot have K1 because axial and equatorial H are identical, there is no steric preference. Isopropyl is bulkier than ethyl, which is bulkier than methyl, so the K order must increase as HCH3 at IPR, corresponding to 1, 18, 23, 38. Therefore, the correct answer is AS, BR, CQ, DP. The correct answer is shown on screen.